All right, so today, now here's what I can guarantee you. First of all, this is not a hard concept, but it is a very different concept. So because of that being very different, then it kind of confuses kids because, you know, a lot of the times you guys kind of tune in, tune out. If you understand the concept right away, this will be a super easy lesson, okay? But like I said, if you're kind of in and out, then this gets a little bit harder here. All right, so. All right, so what we're going to talk about today is what's called slope fields. All right, and what you need is, as you copy this down, okay, we're going to talk about what a slope field here is in just a second. Copy down the equation, and then on the graph, we're going to need, there's 5 points going across here at 2, same at 1, at 0, at -1, and -2. And we're going to put the slope of our potential line in there on each one of those 25 points there. All right, so before we even do the slope field, let's talk about what this is trying to get to, and then in just a minute, we're going to see that what we put on our graph is pretty much going to match what we're going to do over here on the right side, okay? If we know that, remember, dy over dx is the same as y prime, all right? That means we've already taken the derivative of our equation, and we got an answer of 1. All right, if I asked you to take the integral of this, what would the integral of this be? Y prime would turn into a y. What's the integral of 1? Close. X plus c, right? Okay, does that make sense? Okay, now what we're going to do here is we're going to draw in the slope of this line at every single spot on here, okay? Now, what this says is, and this will make a little bit more sense on the next one. This is just kind of to get us warmed up here, ready to go. All right, what this says is at every single point on here, the slope, remember dy over dx measures slope, measures rate of change. It says that the slope is 1. So what I want to do here at each one of these points then is I want to draw in a tiny little line here through each one of these points, a slope that is approximately 1. All right, and they should all be fairly close to the same. They're not going to be spot on. All right, so draw all those in first, and then we'll talk about what this means here. All right, so when your slope is just a constant, that's going to be what the slope is on our actual slope field. Now, why do we do that? Okay, you guys know we just said that the integral of 1 is x plus c. Okay, if we were to graph out y equals x plus c, that could be, let's see if I can draw it straight, this line going all the way through here, or it could be this line, or it could be this line, and so on. Now, these three lines that I just drew in there would not be part of your answer. It's just showing you what's going on here. All right, and in fact, that would go on an infinite amount of times. It would continue on throughout the graph. Now, what is the only difference between these three lines? Is our y-intercept, and in this case, in our equation, it's whatever our c value is. Okay, so what we're doing here is this is called a slope field because it's going to give you the slope of the line at each one of those points. So then we can start to graph out what, if we were just given the slopes, we could graph out all of the different lines that we would have here. Okay, so let's go to a little bit harder one here. All right, and this might make a little bit more sense how we're going to get to this one. So same sort of graph. Okay, we've got 25 different points that we're going to have to do this for. All right, and we are given the equation dy over dx equals negative x times y. Now, this one is obviously not a constant here, so we're going to have to do a little bit more work here. All right, and to be honest, even finding the integral of this is going to be a whole lot harder because we have not done any integrals where we have two variables, have we? Okay, and so, and we're not going to do that today. We're just going to find the slope field for it. Okay, now, what you can do, what I've had some kids do in the past, is they made, I call it like an XY chart, but we're adding in our slope here. Okay, now what we do for this is we're going to do this for each of our 25 points here. Say we start in the middle. We start at the point 0, 0 here. All right, if we plug in 0, 0 into our equation, what do we get? We get a 0. All right, now a slope of 0 would be straight across here. All right, and in fact, that slope of 0 is going to be quite common in this graph, isn't it? Because if we go to the point 1, 0, we throw in 1 and 0 into our equation here, we end up with a 0 also, don't we? 1 times 0 is 0. So this would also be a slope of 0. Where are all the slopes of 0 going to be here? Okay, on the x-axis for sure, because our y value is 0 here. Where else are we going to have slopes of 0? Yeah, up and down also, because up and down, say we put in the point 0, 1, we multiply those together, we also get a 0 here. All right, so all of those points would all be a slope of 0. And all these lines they are just approximating what the slope is going to be here. Okay, so let's go into the first quadrant. Let's take care of these 4 here. All right, so we've got 1, 1, 1, 2, 2, 1, and 2, 2. Okay, and in the end, you're just going to be able to multiply together in your head and then just write down the slope for it. But we're just getting started here. So if we put in the point 1, 1 into our equation, negative 1 times 1 would be a negative 1 for our slope, right? So if we were to put in a negative 1 slope, that might look approximately like that. Okay, and say we go to the point 1, 2. 1, 2 would be up here. All right, we plug that into our equation. Negative 1 times 2, our slope would be a negative 2. Now, what we have to do for that, here's our slope of negative 1. We just got to make it a little bit more steep. Okay, am I going to get a protractor out or a compass out and measure out that it's exactly negative 2? No, you just have to show that this one here is more steep than this one. Okay, if we go to our next point, plug in 2 and 1 in here. -2 times 1 would be a -2. All right, that would be this point here. So these two slopes, do the best you can to get them to match up. All right, not too bad. And then we go to the point 2, 2. 2 times 2, throw a negative out in front. That should be a -4. So this is going to be more steep than the rest of them. Okay. All right, any questions on any of those 4 or anything that we've done so far? Okay. So from here, we just go to another quadrant and we do the exact same thing. All right, so say we come over to quadrant 2 and we've got -1, 1, -1, 2, -2, 1, and -2, 2. All right, from here, -1, 1, we plug that in. Negative times a -1 would be a +1 times 1 would be a +1 here. So this flips into a +1 slope there. We go to the next one, -1, 2. -1 would be a +1 times 2 would be a +2. So up here, we just make it a more steep slope. All right, at -2, 1, that's going to be a +2 slope again. So these two should kind of match up here. And then at -2, 2, -2 would be a +2 times 2 would be a +4. So this is even more steep there. All right. Any questions that you guys can see so far? Okay, so that's pretty much what you're doing for all of these here. Okay, yes, Carl.
So like, what's the purpose of this?
What is the purpose of this?
How would we like apply this?
Okay, so what would happen here is we could draw out a whole bunch of curves for this one. Okay, of the actual shape. Now remember, this is the derivative. This is just measuring the slope here. We could take the integral of it and we could figure out that our shape of this one, at least on the top half, looks like it might be something similar to that. Okay, and you guys kind of see that as I draw that in there. And then remember, when we take the integral of it, it's always going to have a plus c. So we're not just going to have this one. We could also have this one. And they should mirror each other, and they should be able to go up and down there. Okay, now, what happens down here? Well, we don't know yet. We haven't done those, okay? But I would feel fairly confident that those will be the curves for the top half. Okay, and that's kind of the point of it. We're going to get to the point where we can kind of estimate what all the curves are going to be, no matter what our C is at the end. Okay, that's the point of this. All right, does that help?
Yeah.
Okay, concept-wise, doing the slope field, is it hard stuff? Yeah, it's a lot of work. It's not necessarily hard though, is it? Okay, so running through it, we do the exact same thing down below. All right, and what you're going to do, you're going to do it about this fast. 1 and -1, we throw it in there. We get a +1 for slope. Okay, 2, 1 or 2, -1, that'd be a +2 for slope. So this should be a little bit more steep than this one. Okay, down here. 1, -2, this should be a +2. And then this one, 2, -2, should be a +4. All right, so you get something like that. Down here into this quadrant, this would be a -1. So that would be that. This one here would end up being a -2. This one would also be a -2. And then this one here would be a -4. Okay, and all you're doing there is you're just plugging in the points for this. Okay? Questions at all? All right, so we are not going to do that one. You guys, actually, you guys go ahead and do this one. And if you guys get this one, we'll call it good. We're just doing this one. Like I said before, we're kind of to the point now where we're just applying everything that we've talked about throughout the year. So. Now, for a lot of these, are you starting to see that there are some patterns that exist in there? This is one where there's a pattern that exists for practically the whole thing. That's approximately what your answer should look like there. Any questions with what you see for this one or how you're doing this one?
And then like patterns we can know.
Well, no, what's going to happen, like this one here, I mean, there's nothing up front that you're going to know. But if you notice this one, all of the diagonals are all the same, right?
Yeah.
Okay, and so once a pattern like that pops out, especially because this was linear, that's going to happen. All right, if you look at the last one, you know, we didn't have a true pattern here, but what we did have was these two were mirrors of each other, right? And so were these.
So do we know that like if it's like multiplier?
Not a whole lot. I mean, when they're multiplied together, you are going to have mirrors like that, but how it mirrors, it could flip over the y-axis, it could flip over the x-axis, it could flip diagonally. There's really no way to know for those up front. Okay, when it's linear like this, you are going to have a pattern that shows up that's something similar to this, where it's on a diagonal, but whether it's a diagonal this way or a diagonal this way depends on the problem. Okay. And that's pretty much it. I do want to show you this one really quick because we are dividing here, aren't we? Okay. And I'm not going to do the whole thing here. I'm just going to show you a couple points here. All right. If we do the point 0, 0 here, if we plug in that point of 0, 0, what do we get for a slope? We get it undefined. So what that means at that point is you would have an asymptote in there, right? Okay, now how you show that on a slope field is there are technically two ways to do it, and nobody uses one of them, so there's really only one way to do it. Technically, if you wanted to, one way that we've shown an asymptote in the past was we put a dashed line in there. I know that's really hard to see. If I go up here, let's see, no, if I go over here, it would also be a dashed line. Now, I wouldn't necessarily do that, okay? Because, like I said, most people don't do that at all. Instead, what they do is they leave it blank, all right? And if there's a blank spot in there, that just means that there's an asymptote, okay? So for this one, whenever your y value is 0, and that would be for all of these points here, we would have an asymptote there, okay? So just leave it blank and call it good. All right. For the rest of it, it all stays the same. Okay, so it's no big deal there. All right, any questions at all? All right, I picked this one today on purpose because I know that a lot of you still have a lot of the area between the curve stuff to get done. Okay, so make sure you get that done. Make sure you get that taken care of. Get it all figured out. All right, if you have questions on that stuff, you let me know. All right, but then I do have this worksheet for you here. So